Hello. In this video, the last minute professor is going to explain how to generate n terms of Fibonacci series. Some call it Fibonacci series, whatever be, using two methods, iteration and recursion. What is that series? It goes like this: 0, 1, 1, 2, 3, 5, 8. Sounds different. Keenly look into the pattern. How was this series generated? Let us peep into it. The first two numbers are 0 and 1. Following that, there is a pattern. The next number in the series is generated by adding the previous two numbers. That is 0 and 1. So 0 plus 1 is 1. Now the last two numbers are 1 and 1. Next number would be 1 plus 1 is equal to 2. So print that. Now 1 plus 2 is equal to 3. So that and so on. How to generate n terms of this series using iteration. Step number 1. Get the number of terms from user as n. Example, n is equal to 4. Step number 2. Here we have count, a variable to track the number of terms printed. Then variables a and b to store the values of the last two numbers. Initialize count to 0 as initially we haven't printed anything. Now initialize the first two terms of the Fibonacci series in a and b. So a is equal to 0 and b is equal to 1. Step number 3. This logic is written with an assumption that the user gives number of terms input as positive integer, that is n value greater than or equal to 1. In case the user gives the number of terms needed in the series as 1, the first term has to be printed, that is the value 0 has to be printed. That is what is given here in the if. But here in the example that we have taken, n value is 4. So this if part gets skipped and the control passes to the else part. Print the values of a and b. Since n is not equal to 1, so this becomes false, and here the control comes now. The values of a, the value of a is 0 and the value of b is 1. So that is also printed. Now set count is equal to 2. That is, since we have displayed two values 0 and 1, I am making the value of variable count as 2. Now we have to print 4 terms. So repeat the steps till count reaches n value. So now the value of count is 2. So till it becomes 4, we have to repeat these steps. The next number in the series is obtained by adding the last two numbers. So the next term C is equal to sum of previous two terms A and B. So C is equal to 0 plus 1, which is equal to 1. Now print the value of C. Now we have printed one more term, so increment count by 1. So count is equal to 2 plus 1 is 3. Now the last two values printed in the series are in B and C. So let us assign them to A and B. So A is equal to B and B is equal to C. That is, A becomes 1 and B becomes 1. Repeat the statements while the value of count is less than n to get the n terms of the series. When count reaches n value, the condition fails and the control gets out of the while loop. The same Fibonacci series can be generated using recursion. Recursion is the function calling itself. What is a base case? A situation where there is no further function call. So in this scenario, it is when the value of n is either 0 or 1. As we know, the first two terms of the series are 0 and 1. So this step helps in retrieving those values. So if n is equal to 0 or n is equal to 1, just return the value of n. So this is the base case in this recursion. For other values of n greater than 1, that is else, failing which you are moving to the else part, where Fibonacci of n is obtained by the sum of the last two terms. So Fibonacci of n is actually Fibonacci of n minus 1 plus Fibonacci of n minus 2, the previous two terms. So for example, say n value is equal to 4. Here initialize count as 0 because we haven't printed any terms in the series yet, while count is less than n. So now 0 is less than 4. Print Fibonacci of count, that is Fibonacci of 0. So it comes into this part, and here as we know Fibonacci of 0, so n value is 0, so return n, so 0 gets returned and that is printed here because we have given it in the print statement. Now increment count by 1. So since we have printed one value from 0, the count value becomes 1. Then again, what we are going to do, we are inside the loop. So now count is less than n. Yes, 1 is less than 4. So now Fibonacci of 1, that is n value is 1 and so return 1. That value gets printed. Now increment count by 1. So it becomes 2. So we have printed 2 terms. We are ready to print 2 more terms. So now the count value is 2 and 2 is less than 4. Yes. So now Fibonacci of 2. So Fibonacci of 2, when it comes, this part fails and so else gets executed. Return Fibonacci of n minus 1 plus Fibonacci of n minus 2. That is Fibonacci of n minus 1 is Fibonacci of 1 plus Fibonacci of n minus 2 is Fibonacci of 0. The previous two terms gets added now. So 0 plus 1 is 1. That value gets printed and the count gets incremented by 1. So count becomes 3. Now 3 is less than 4. Yes. So print Fibonacci of 3. So Fibonacci of 3 is nothing but here else part will get executed. So Fibonacci of 2 plus Fibonacci of 1. That is the sum of the previous two terms. So it is 2. That's it. To encourage and support this work, do like, share and subscribe. Thank you for watching.